So we're switching gears, huh?
Yeah.
Do you see my screen?
Yeah.
I'll make it bigger. So I have small change, but maybe like interesting one. I have two different versions related to my previous one. And I removed the final representation.
You removed it? I finally was starting to understand it.
I wanted to see how this will look like, but this is not like a completely true. I removed it, but you know, you will see where now this part was like going into the syntax, and yeah. So the biggest change is this.
Hey, I have a question real quick. What is the G in GADT?
Generalized.
Yeah, generalized abstract data types. Is that what it is? Yeah.
Okay. Yeah. And generalized in a sense that you can have different constructors. You can have constructors that return different types. And this is exactly how I defined it. So before I was using type families, and with the type level functions, I can return different types. But in this case, I'm not using the type families. I'm just using the IDs. And I hear some echo. Okay. I have two type alias, so I can write it just with one word. These types. So I can have the processor name like a different types, but with aliases I can like specify it with the same name as before. Is this make sense?
It's it's starting to make sense. Let me see if I can repeat some of it back there. So 12 and 13 are simple type aliases, right? You're just making up a new name. What's already defined as row of our process, you can now call process. So nothing too high-minded there. Your constructor for row, or I guess the data type declaration for row starts on 15, and it's parametric in one other type P, right?
Yeah, and this is the type that I'm constructing here. So I can return it and say, okay, I have like a special. I could write in all of these cases like this. I could create a new type, but with aliases I can just say this is a process. But I'm creating two different types. I have a row constructor. This is like a row type that is parameterized by P, and I have two different like a variant of this type.
Yeah. Okay. So here's a question. Here's something that's not familiar to me. After like on line 16 through 27, you just have type declarations for your constructors, right?
Yeah.
Where are the? I don't know. Doesn't it like either?
Maybe I can write maybe type in JDT.
Oh, that would help a lot. Yeah.
Maybe A. And now I want to specify my constructors. So my constructor just is something from A to maybe A. And I have another constructor, nothing, which doesn't accept anything. It's just maybe A. And when you compare this, this is probably clashing with some existing.
With the real, maybe?
Yeah. And with a regular data type, this is we are specifying constructor like in shorter in a shorter way.
Oh. Yeah. Okay. So the fact that it gives back a maybe a, it should be totally clear, right? Of course, that's what it's going to give back. That's what data type it is.
Exactly. So, this is just constructors, and here you don't have a way to specify I'm returning something. You always returning maybe a. This is like this is implicitly defined. You don't have a way to say I will return something else.
Right. Okay. So now, but you do have a way to say that. Oh yeah. Right. Okay. So let's say you want to make your maybe prime type like a little bit exotic and add like a third tag in there or something. Like, how does that?
Yeah. I could say I have maybe some label here, for example, and I can say this is Boolean and this is integer.
Mm-hmm.
So in a sense, I'm returning two different types.
Yeah. I think this makes a ton of sense. I don't know how to put my finger on the fact that it feels weird to do it in such a strongly typed language like Haskell, I guess. Like, what does the type checker do for you here? What can you write right where your cursor is? What other things other than bool could you write there?
Oh, you can put any type here.
Yeah. Okay.
So your label now is like a type parameter?
Yeah, and this type can be or Boolean or int.
Mm.
So you can pattern match on this type also.
Okay. Mm-hmm. Mm-hmm.
Oh, interesting. Okay. So your purpose for doing it here is something to do with giving back names or processes, I guess?
Yeah, I want to have this distinction. And
okay.
Yeah.
And so process is always, so that's why, okay. So when you did,
and this is why I'm calling this label, because I'm using this as a label.
Yeah, right. And that answers my question about lines 9 and 10. You just defined a data type with no constructors there, and that's because you're never going to make one. You're just using them as labels.
Yeah.
Okay.
I could use like a Boolean. No, I couldn't use Boolean. I must have two different types.
Okay.
Yeah, they don't have constructor. They're just there to be.
Sure. And you're only going to use them for like pattern matching, I guess, or something? I get that you can distinguish, like when you get one of those stop things. Oh, wait, actually.
They're really types, so I don't have to use it anywhere.
Mm-hmm.
Maybe if I want to construct, if I want to specify these types, but I have aliases, so probably I'm not using it anywhere.
Wait a second. Maybe I missed this, but so row on lines 12 and 13. That's a type constructor.
Oh, this is just a type alias.
Just the type values. So okay.
Type alias.
Alias. Oh,
alias.
Okay.
Alias.
Okay.
Yeah. So the row that he has highlighted is, I think that is a type constructor. It's the row that he defined on line 21.
Yeah, row is a type constructor. And I'm giving.
Okay. I didn't realize 21 was the definition of row. Yeah. Okay. Cool. That makes sense.
Haskell has forward reference, so you don't have to do things.
Yeah, that shouldn't confuse me because that's K framework is the same way.
Yeah.
I think I could do something like that, and everything will work. Because I'm not interested in values of these types. I'm just interested in two different types.
Yeah.
Right.
Okay, this is pretty cool. Okay, so the big value add here is that all of your things are type row something. All of your names and processes and everything are rows of some variety, and then of which variety, name or process, you have to. That depends what P is.
Yeah, yeah.
Okay, this is pretty cool.
Yeah, this is exactly from this paper that I shared on Discord.
Oh,
and I was reading this paper
cool.
again, and I was thinking, let me try this one.
All right, so maybe
where did you share that in Colab?
I don't remember.
Yeah, it might have been in the Haskell chat.
Oh yeah.
But I put it in the README file here in this repository.
Oh, nice.
Cool.
Okay.
Cool. Yeah. So what is this maybe prime thing doing again? I know you were talking about having that type parameter there and being able to pattern match against it, but I don't think I understand what you're using it for.
This one.
Yeah, well, no, just like that entire maybe prime construction there.
This is the same thing as this one, but without label.
Yeah. Okay.
It's not used for Roland. He typed that in there just to help me understand this.
Oh, yeah. That's what that big
I'm already
bar
familiar
is all about, right? Okay.
Yeah. Yep.
Okay. Oh, see, I'm familiar with maybe, not maybe prime or maybe double prime.
So this is this maybe prime is example of how this construction works.
Okay.
Because I added this type to this to have distinction between two different constructor that I want to have.
Okay. Yeah.
Because I want to have one data type.
Yeah.
That have some constructor that return something that I can distinct from the other constructors. So I can have this constructor that return a process, but this constructor returns something that is like a name.
Mm-hmm. Mm-hmm.
But they're really almost the same. Only difference is this label, this P.
Yeah.
That is supplied to this type constructor.
Yeah. Okay.
Yeah, this is cool. I dig.
Mm-hmm.
So you're showing us row length 3 right now?
This is row length 3.
Oh yeah. Right. We're looking at row length 4 on the left. Yeah. Okay.
Yeah.
Nice. Okay. And then data ground.
So before I had two different data types, one for process and one for names.
Mm.
And now they are in the same data type.
Yeah, that makes sense.
Together, but I have distinction between these two constructors.
Mm-hmm.
And all the other stuff are the same. On ground is still part of the names.
Mm-hmm.
And yeah.
So I'm looking at how you did your ground terms now. That data type at the bottom makes perfect sense. And then on line 33 is where they get embedded into processes, I guess, right? What's the NP right there?
That's the name or process.
And NP is
a similar thing. Yeah. Okay.
Yeah.
You remember this distinction? How you bind
That's
a variable?
That's right. I remember. Okay. Cool.
Yeah.
This is looking really clean and actually making a lot of sense. That's super cool.
Yeah, I want to better understand it. I must have it like a clean.
Yeah. Yeah.
So let me ask you a question here. So the difference between your 3 and 4 here, is this just so like what? So I mean, I see there's some syntactic differences, but I guess what I'm asking is like, is there a philosophical difference, or is there like something really concrete that distinguishes these two that like makes one of them better than the other? I guess is kind of what I'm asking.
So just from the point of view of this data types is almost the same.
Okay.
So these regular data types are with these regular data types you cannot make it something like this because you don't have ability
to separate the names from the processes.
Yeah, you must like define two different data types.
Yeah.
And with GIDTs you can define only one data type. And
okay, and by regular
other different. Yeah.
I was just going to ask, by regular data type, you mean one that doesn't have one of these type parameters, right?
No, just type parameter, because you for example, in this maybe you can have a type parameter.
Yeah.
You have this type parameter, but if you are returning always the same type,
yeah,
then there is no distinction between regular data type and generalized. But if you want to have some like a more complicated data type, then you can add something else, some other parameter, and return for each of your constructor a little different type. You cannot return like a completely different type. This is not allowed. You must return maybe, but you can change it in some other parameter, like a difference.
Cool. Okay.
And I don't know like some deeper implication for this.
Okay.
So, Tomislav, is there like an evaluator or what kind of?
I have duplicated the whole thing, so I have everything.
Nice.
And so, what is the difference with? So, I don't have a final definition from before. So, this final definition now it maybe will be more clear what this definition represents. So old semantics is this still visible or is it too small?
That's okay.
Okay. So in old version, these instances of this final representation, it's really the connection between this like abstract language of functions and concrete structure of initial representation. So all this syntax erasure happens in this transformation. And I don't have the final representation here, so there is somewhere else this conversion is happening, and it's visible in the parser, in the syntax. So the parser was not changed, like nothing, but the functions that are the parser are using are not like an abstract final representation. They are really the concrete structure from initial representation. So
the one you showed us with the GADT.
Yeah. So if we look the four parsing of four expression, then in we're looking at this wrong. This is the newest.
Oh.
Sorry for no, not 4A.
It says 4A. Yeah.
No,
Oh, you're looking.
I don't want to show for a yet.
Okay.
So in the old representation, I'm using this for. This for is a function defined in a final representation, and with JDTs, I'm using the concrete constructor of the input of the for.
Mm.
That's just one of the constructors that you showed us from the GADT, right? Input is?
Yes.
Yeah,
Yes.
Okay. Yeah. Right. Okay.
And in old version, I'm using this for from final representation.
Yeah.
So this is like a subtle difference, because I'm using the specific structure, and here I'm using the more abstract definition.
Yeah.
And this from this, it's visible how this instance is instantiated. This for is really an input.
Oh.
This is like the same function, but it is not written directly in the parser, but you have like another level of abstraction where you can specify this what function in your final representation is connected with your initial constructor.
Right. You had this line 21 was an opportunity. It's another level of indirection and an opportunity for you to do something fancier than just use the input constructor.
Yeah.
Although you didn't need to. But then like in the new one, you just have to use that input constructor directly.
Yeah. And for example, this eval or quoting, here is the place when you can specify this syntax erasure. And on this side, this must be written somewhere. So I made these two functions. And these two functions are really like a final representation in a sense. So I'm using eval almost the same as previous.
Mm-hmm.
But you can see it. This is just a function. This is nothing special. And this is like an exact copy from the previous implementation of with the final instruction.
So you're removing the star quote towers at parse time before evaluation begins?
Yeah. Immediately when after parsing.
Yeah. Oh, that's super interesting. And I know you're using multi-sets for your parse, so that was never a problem.
Yeah, and this code for constructing a multi-set from a par. Now this is part of in the parser file, because you don't have this abstraction. You must write in the parser. So this is why this abstraction is nice, because you can abstract your functions, your language, and not work directly with the structure.
That's interesting. So Tomislav, where is your oh, this is your row parser that we're looking at literally right now at the bottom of the file, right?
Yeah. And so it's the same from the first version.
So it takes can you help me read line 107? I'm not sure how to.
Oh yeah, I'm using this parser.
Yeah, what is that one? Yeah.
It is a way to specify syntax when you have something like a par or a plus for integers, for example. So you have.
This is like at some point I had used like sep by or something like that.
Yeah, but this is like a specially defined for syntax like this.
Oh, okay.
Because you can have different well, I'm not sure right now. When in this situation, it's difficult to write it yourself because
Yeah.
you must take care because you have recursion and you want to have the same type on both sides.
Oh, interesting. Okay. Okay. And then the part after what you have highlighted is that's just applicative, and you're saying like basically return the results of this function on 108, which is putting it into a multi-set.
Yeah, exactly. And I'm saying you will have this p proc separated with the pipe, and you just repeat this multiple times. At least one p proc must exist.
Yeah. Oh, that's what the one. Oh, is there also like a chain without the one? Yeah, that makes sense.
Yes, exactly. Yeah, yeah.
Nice. And then, okay,
I think
and row parse that's the big thing, right? Oh yeah, yeah, I see. Parse P and then the empty string and then run. Okay, cool. Oh wow.
Yeah.
Yeah, this is really looking. Oh, here's something I didn't ask about before. What's all the pproc 1, 2, 3? Like 90, line 96 ish. Yeah.
So this is like very very similar. How it's defined in the rolling BNFs in the definition.
Yeah, I've seen that. They have like 20 of them in there.
Because
this is for precedence.
Not only for precedence, because I want to have proc 2. So proc 3 and 4 are really to define these curly braces, so that you can have that you can say either you have a process expression that is one word or something that is not break something that doesn't have a space, and if you have something that has space, then you want to have these curly braces around it. So you can say, okay, this is like the same thing. If you put curly braces, this is the same.
Mm-hmm.
So I need some kind of way to say they are two different things, but try this first without curly braces, and if you fail, then try with the curly braces. So it must be correct with the curly braces.
Oh, interesting. Yeah,
Okay.
Framework has a really nice way to parse this like braces, and you just give it a bracket attribute, which is really nice.
That's so nice.
I was wondering with your the way you're eliminating like quote eval stuff and eval quote stuff. You know, I have a structural attribute to my rule that takes care of that, which essentially just means geez, I guess I don't 100% understand what the structural thing is, but my understanding of it was that like it's not actually generating transitions for those things. It's kind of just like reducing them before it applies things that I actually consider as transitions. So like basically comms are like, well, comms and like rearranging terms are the only way to do transitions in the system. But I didn't want this like star at business to actually be one of those transitions. I just wanted it to eliminate all of them immediately. So I wonder what you're doing, if it even differs from what I've been doing.
Well, I think it's almost the same. This is like a definition on part of syntax, right?
Yeah.
Okay.
Yeah, more or less.
Yeah. In that sense, this is like totally the same.
Yeah, cool. Oh, I had another question. It's like kind of a general question about Haskell, and I'm wondering if you've encountered it in doing this stuff with your row parser. So like, what kind of control do you have over multisets in Haskell? Like, can you explicitly like have some multiset that's being built by whatever process you have running, and then like say like, okay, I want to take one element out of this multiset and then like the rest of the multiset I want to do some operation with. Can you do things like that in Haskell? Because I'm trying to figure out how to do that in K-framework and not successfully accomplish that.
So I'm using this multiset library, and you have almost all it's very similar to set library, and you have operations that you expect from a set or multiset.
Yeah, that's great. Okay, so
you can make a union. You can make yeah.
Okay, cool. Yeah, so you have like element inclusion predicates and that sort of thing, and you like you said, you can do unions.
Union difference.
You can actually work with a multiset like a variable, and just apply whatever operations you want to it.
Yeah, and it's immutable, so you can easily.
Yeah. And
works. So maybe you notice that I have ordering from my data type, and I must have ordering because this library and this implementation of multiset uses ordering as a way of it uses ordering in the background to keep track of elements.
Okay,
but
so
there is another
So you're saying like if you were to put two things that are syntactically the same into your multiset, like it actually takes one to be before the other one or something along those lines. Like they actually have some ordering to them, or
it is just a matter of implementation. How do you store keys, and how do you get the element if you know the keys? Because you have some guarantees about how expensive is to get the key or find the key or find if the element exists. And so this implementation uses ordering to probably with some kind of binary search.
Okay.
But there is also implementation that uses hash. So you don't need ordering if you hash it, the key, and then you use this hash.
Okay.
But I'm not sure. Well, I first want to do it with this library and then try it with some other. But yeah.
Okay. Cool.
And because it is constrained by ordering, some operations are not general. So for example, you cannot define functor for set or multiset because it has ordering constraint, and you cannot define instance of functor that have ordering constraints.
Okay.
So yeah, and semantics. All the other functions are really the same. Yeah.
Man, that's awesome. So is this like fully up and running now? Like you can type in any rocalc term at least, and it'll parse it correctly, and
yeah, it's working like a version before. Yeah.
Yeah, great. Oh, awesome.
Yeah, you have substitution in the bound names.
Cool.
And now I want to show you the 4a.
I was wondering if we were going to get to see it today, or if it was still a work in progress for future.
No, it's very similar. It's all the same, but you can see the difference here. I don't have any parameter. Everything is process. I want to try yours.
Oh, nice.
Procalc.
But I didn't change anything else. So the parser is still parsing like a star and the at.
Oh yeah. You still have star and at constructors, but everything's just defined over processes.
Yeah, but I will try to remove it from the syntax and see how it works.
Well, I mean, actually, like Tomislav, that's kind of an interesting idea because you'll still be able to parse Colab Rolang. Like programs that were intended to be run with our node will still work here. That's
right.
kind of a strength, really.
Yeah, that's what I thought your goal was, Joshy. Like make everything processes, but still have all the same syntax if you want as like an alternative syntax, basically.
That was and is my goal, but I took a much more naive approach where I just am parsing. And anytime I want to parse a variable name, I parse it as 0 or more optional stars and ats, and then the actual variable.
Oh, yeah, okay.
Oh, you're saying you're just ignoring stars and
yeah, that's right. That's right.
Oh, cool.
I don't know if it will work yet. It's just a naive idea I had, and my thought was like at least in simple cases it will make the codes still run. I haven't put enough thought into it to like know that that's a good idea that will work or anything.
Mm-hmm.
Yeah, this makes sense because now I want to remove from the syntax everything and just have the process without stars and quotes.
Yeah. Oh, interesting. Yeah. I mean, as you know, I'm a big fan of that design. That's cool.
And in this state, everything is a process. So when you parse something, you can make mistakes because now the syntax have this difference, but you put everything in the process, and so now it's half is aware of this difference and half is not. So yeah, now we have a situation that when you're parsing a name, it can be a process, and yeah. Mm-hmm. I really don't know. Is there any problem with this? And
I don't think there should be, man. Like they're isomorphic to one another. We should just be able to treat them all the same.
Yeah, I also don't know for sure, but my instinct is that it will work. But whereas I like to think of myself as like mostly a math person, that's really not reality. And reality is the only way I know is to try it out and know when I get stuck.
Yeah, see if your code compiles.
Yeah. Yeah, exactly. Wow, Tomislav, this is very cool, man. I mean, so like, how close are you to being able to run some basic like Rolang code? You know, like if I were to do one of the Hello World examples or something that's on our chain cloud, do those? Oh wait, have you shown us com events?
Yeah.
I didn't have time to.
When is T Node 0.1 coming out?
Yeah.
I didn't have like a big chunk of time, so
yeah.
Oh, I mean, I'm impressed already.
Sorry,
I'm impressed with what you have done for sure.
Yeah, this is cool, man.
I'm just like a circling around like the same thing, and now I want to do com, and I hope I will have some time next week. Next week after that, I will definitely have time.
Nice.
So, Tomislav, I have a question about Haskell. What kind of concurrency can you get with Haskell? Like, does it? I mean, like, I guess I'm not 100% familiar with the semantics of Haskell, but does it allow for? I mean, does it have like a threading kind of concurrency model, or is it something different?
Yeah. You have. It's usually you have threads, but
threads like Java.
Yeah, but you usually don't work with the physical thread directly. So you have like this green threads layer above.
Okay.
And in Haskell, there's different libraries that you can use for this purpose.
Okay.
This STM is like a popular way that you can.
Oh yeah, I see that everywhere in the in all of the K reference documents. That like all their definition files, they all have these STM libraries where they're like giving a notation or a name to certain things that they're defining. Or SMT. I don't know. Yeah, I don't know what it is though.
It's transactional memories.
Mm.
You know what is?
Mm.
Yeah, but I didn't use this. So I was on the Haskell summer school last year in Poland. So we had one lecture of one track about STM. So that's all I know.
Oh, okay.
Yeah, but basically you have a box, and you don't manipulate values directly. You manipulate with these boxes.
Mm.
So you can take the reference of the box and make some modification. And library ensures that only one thread is accessing this box.
Mm.
So it's not easy, definitely.
Mm-hmm.
In any normal language, this is not easy. So
Yeah.
you must take care of synchronization in some way.
Mm-hmm. Mm-hmm.
But in Haskell, yeah, it's pretty nice because you have this helper functions that you can have. You can say this is like a forever and repeat and this kind of stuff that you can
Mm-hmm.
express some kind of, I don't know, dynamic execution or
Mm-hmm.
temporal execution.
Mm-hmm. Yeah, cool, man. Yeah, I honestly actually think I need to get going here, guys. This is really cool, man.
Thanks.
Yeah.
Josh, are you interested to show something of your work? I'm interested to see.
You're muted.
Oh, you
I can show you what I did on Bloxy, and I started writing what I was calling Roxy. I started rewriting it in JavaScript, and I've taken Glenn's approach of using JSON for the AST, and so far it's working pretty nicely.
Mm.
Oh, cool.
Yeah. Let's see.
So you said that's what you're doing for Bloxy?
Yeah, for both actually.
Oh, okay.
I decided that I'm not a sufficiently good Haskell programmer to dive straight into doing Rolang that way, and the best way for me to work on that is to learn from Tomislav and contribute when necessary, or if I feel like I'm able to.
Mm-hmm.
If I can say, you're a very quick learner for Haskell.
Yeah, well, thanks. I mean, I also feel like I've learned a lot, and it's mostly because we've worked together on this. So I really appreciate it, definitely.
Because usually I didn't see someone like that quickly to understand, you know,
Nice.
Especially if they are working on some like a C type language.
Okay, so let's see. This is my new parser. There's this Node.js package called Nearly, which I'm using for my parser now, and it looks a little bit crappy right now, and that's because I was excited about getting it working and introduced some like technical debt. Like all of this stuff is JavaScript that should be moved to another file and will be moved to another file in due time. But I love this because it works like as magically as almost as nicely as the K framework one does. It doesn't have the bracket thing, which I really want. But what I love is that I can just do like proc has these forms. It can either be a string NIL or it can be oh wait, how does this work? Oh yeah, or I defer to my channel parser and then white space, and you can read it.
Mm-hmm. Yeah, this is like a parser generator.
Yeah, this is not a parser combinator. That's right. And I do miss that because I liked the parser combinator idea, and I just learned it. But I felt like I was really cruising through this. So
all right. So for a total noob, what's the difference between the parser generator and the parser combinator?
Oh, for example, like a BNF syntax. From BNF syntax, you have parser generator that that will generate a real parser that will like run and work.
Yeah. Okay.
So this is like a different specification. It's not BNF, but it's specification for this parser generator. But you can read it like a BNF.
Yeah. Okay. Mm-hmm.
You have these rules
Mm-hmm.
that you can name, and also you can say with pipe you can say different rules.
Mm-hmm.
And in this like a template curly braces,
Yeah.
you're specifying your JavaScript code.
Yeah, this is what they're in nearly vocab is called a post processor. And yeah, exactly. It's a JavaScript function where it takes in a super long list, and the list is it's a channel and then whatever white space I parsed and then an exclamation point and etc. And obviously I only care about some of that. And then what it returns is this JavaScript object. And this is, oh, Isaac, this is cribbed almost entirely from your K-framework trees that you were talking about a couple of times.
Yeah, cool. Okay. Yeah, that makes sense. Right. It's like the structural type or whatever.
Yeah, like this is where you can really see, because I think yours was like leaf nil, right? And I just chose to use round instead of leaf, and other basically the same as yours.
Right. Okay, cool.
And then, oh yeah, and so then there's this channel parser, because so far what I've been doing is requiring that when you use a process as a channel, like when you're using it in a send or receive, an at has to come first in the syntax. Mm-hmm. Not that thing's actually a name or anything like that. It's just that the syntax should be at whatever, bang whatever, as opposed to just, without the at sign. And then I have it parsing joins pretty much. I still have a to-do here, but all of the receives are parsed as joins. And so like even a simple linear listen is actually a join of one action. So, why is that changed? What did I modify? Oh, I don't know why it's telling me that file's changed, but so I can do this npm run compile grammar, and this is gonna, oh yeah, this is what I was stuck on when I left off last. So like in all of their docs, it seemed like they have main comes first, and then it just, because what the top level thing that Nearly is going to try to parse is whatever production is first in this file. So like it was process, and then most of them that's fine and it works. But most of their examples have main pointing at something, and just as a nice way for like when I want to later test actions specifically or whatever. And so like I got stuck, and I just figured I should figure out what those error messages mean. But if I ditch that line for now, then I can compile my grammar without warnings. So it took this NE file that I wrote, and it generated for me grammar.js, which is just a regular old JavaScript file, and does all the parsing for me. So I can't remember what I have. Let's just see what this does. Oh, okay. It parsed one particular thing, but this is another cool thing that you can do. Nearly test, and then I tell it what parser I want to use, which is this one that I just generated. And then I can give it anything to try to parse. And so I can give it, for example, like at nil, bang nil.
Oh, cool.
And, but Bash doesn't like that. And it's not even in my history. That's BS. Okay. Oh, wait, what did it not like? Bash exclamation point event not found. I thought the quotes would solve that. Darn it.
What if you run it without the quoted stuff? Does it say it's expecting some kind of input?
Oh, without literally.
Yeah, like nothing there. Yeah, exactly. Just dash input.
Yeah, I mean it parsed.
Oh, I was wondering if it would then ask you to input something.
Oh, I'm pretty sure that's the correct way to do it, right? Like it parsed that correctly. It's just that for whatever reason, Bash. Oh, maybe I can escape that exclamation point. Let's try that.
Oh, huh.
I think Bash thinks this at is the problem.
Oh, really?
Maybe it try to find the variable, you know, with the at.
Oh. Oh.
Can you escape the at?
Anyway, let's just try a different one. This is clearly a bash problem, right? Not a parser problem. So let's try this one. For x from @nil, then do nil. So it tells me that the top level thing is a join. That's correct. The body was just nil.
Mm-hmm.
And then the actions is a whole list, but in this case, it's a list of only one item, which looks like this. And so, you know, it's got tag action like all actions do. And then it has a pattern and a channel. So it's going to receive something that matches this pattern, just a variable called x, from this channel. And notice that's the same AST that always means nil.
Yeah.
So it's given me these nice JSON like ASTs basically, and I think it's going to be pretty quick to get that parsing at least most Rolang programs. So I'm really excited about that one.
Mm-hmm.
And then okay, I don't need to show all the details of that, but I do also want to just show you this. Okay, wow, I didn't expect it to take so long to open a local file. Oh, there we go. Okay. Maybe that's just browser boot up time. Okay, so I only have some blocks right now, but we can just imagine I do a simple one here, like @nil bang nil. So this does two things so far. It first of all can generate that same exact kind of AST like I was just showing you in the same JSON.
Mm-hmm.
So you know, you can still see like this is the same exact nil ADT and the oh, I didn't do parse. I think parse is going to be my next thing in Roxy. That's obviously pretty important. But the other thing you can do when you create one of these is generate a string of syntax that you can actually just pipe right into our node eval and run it with the co-op interpreter.
That's cool.
Cool.
It seems to work okay so far for the ones that I have. And if you have like different top level scripts, they're all just considered parred together. So you can see all those nils parred in there.
Oh, nice.
And they nest pretty nicely if you can get the blocks to work the way you want. So it does pretty good given co-op strings. I haven't quite figured out this white space issue, but honestly, I might not. It might just not be worth the time to figure it out.
Mm-hmm.
I think if anyone ever actually uses this, they're basically gonna like consider this their code, and then this is just some intermediate thing that they have to deal with to get it over to the interpreter that they don't know how to read or whatever.
Mm-hmm.
Or it would be nice to have some kind of visualization that Greg was describing.
Yeah.
Oh yeah, what are you thinking of? How's that work?
Well, I read this Google Docs about visualization, but yeah, I'm not sure how to do it.
Oh, the visualization. Oh yeah, like Isaac, like you were talking about.
Yeah,
about the geometry.
Yeah.
Oh, that would maybe not be that hard. Like there's good graphical libraries in JavaScript. Once we have an AST, that might be possible.
Yeah. I was thinking, you know, what's his name? Dr. Groot. I'm not sure how to pronounce it, but either way, the modal formulas professor. He showed some label transition system software where he was like generating like like a graph for a label transition system, and he could like apply different reductions and stuff to it. It would be great to have something like that for like rolling programs, you know?
Yeah, totally. That makes sense. One way that I started thinking about doing this, maybe it could be better done as a label transition system.
Mm-hmm.
The thing that I had thought originally was that I would take all the top level sends and receives, put them in the tuple space, and then present the user with a list of possible comms where they choose the possible comm, and then it reduces and does the same thing with the new tuple space.
Yeah.
But yeah, presenting that in a way that it makes sense to a user and isn't overwhelming, it may not be trivial.
Yeah, that's going to be hard.
And this visualization that Greg was describing, this is like a 3D representation, or I cannot visualize.
Well, it's a 5D representation, I guess, but yeah, because he basically wants a distinct dimension for each one of the constructors, so you can kind of just like look in that particular direction and tell if there's like one of these terms present in your program.
Yeah.
Yeah, and basically his thinking was just from like visual inspection of this like geometric object you produce, you can tell that there will be options and that sort of thing. I'm not sure it's clear that you can tell there will be reductions and also what those reductions are directly from the object itself, though.
Yeah, I didn't realize it would be the case that you could visually tell there would be reductions. That sounds cool.
Yeah.
Yeah.
Cool.
Mm-hmm.
All right, guys, you want to call it?
Yeah, we could call it here.
Cool. All right.
Sweet.
Well, good session, everybody, as always.
Yeah, thanks for showing, guys.
Yeah, Chinese community, cool that you guys are here. It's awesome to have everybody. Feel free to speak up too. Yeah. Thanks, Jim.
Yeah. Thank you, Jim.
Thanks, Jim.
Thanks for joining, guys.
See you. Bye-bye.
See you later.
Oops, I guess I missed the ending. I'll leave the room open. You guys can continue.
So he came up with this notion of how do you evaluate these cultivations and how do you calculate anyone's fair share.
Can I ask you a clarifying question?
Sure.
When you say